Hi, in our previous video, we show a few information generated by Dgrai in terms of their total quality. And also we did a very small analysis in order to realize if the generated data was enough or not. Now, let me explain what this really means. So in the same spreadsheet, I'm going to create an additional sheet here. So I'm going to simulate that I have generated a few quality values. So let's say that I'm going to say this is the column time, just to use the same notation. So this is going to be total quality. Right, something like this. So I'm just going to generate some random values. So I'm going to generate a value which is called rand, and that's it. So that function, what it does is that it generates values between 0 and 1 randomly. So I'm going to generate a few values. Let's say 10 values. So let's say that this is the time as we saw on Dgrai is every 60 minutes. So 60, 120, 180. So let's do 10. So till 11 there. So, and also as you can see, because this function is generated by Excel, so it changes constantly, right? But let's presume that those are the values that were generated by Dgrai. So I'm going to just copy them here. Then I'm going to paste their values in order to fix the values. You see, otherwise they will be changing all the time. Right, so let's presume that those are the values. So how can I know if those values are enough or not? I mean, 10 periods of simulation were enough, or shall I simulate more? I don't know. I need to find that out. So for that, I use the average cumulative value. So here I'm going to just generate one column just to understand which value is this. So this is the number 1, this is number 2, this is number 3, sorry, 3 till 10. So like that. Now here I'm going to introduce the accumulative value, right, like that. So the first value always is equals to the first one, because there's no one previous to that one. Then the second value is the second one plus the previous one. So then we have the accumulative value for the second value. So then I just replicate this formula till the end. So I can see this is the cumulative value. Actually, I can have a look how this looks like. So I'm going to insert a graph. Like this. See? So this is the cumulative value. So as you can see, this value is going up all the time. See, it's going up. But are those values enough for my simulation? Shall I run more values? Okay, so let me introduce. So I just delete the graph by mistake. I'm going to delete that here. Just here. I'm going to make small this spreadsheet. There. So are those enough? I would say I don't know. Let's find out that. So for that, I generate the average cumulative value. So for that, here I create the average accumulative value, like that. So I just need to divide the first cumulative value. No. Here, this one divided on this number. So, and I replicate this till the end. Now I'm going to graph this column. So let me see what happens. I'm going to insert that one. So as we can see, the graph of the average cumulative value does not look stabilized, which means that it's not aligned. So I can't say that there is a pattern, right, in this particular figure, right? So probably I need more data. So let's see what happens if I add more data. So let's say that instead of having 10 values, let's do 50 values. So those are 10. So 10 more will be 21, like there. Another 10 more will be 31. We go 30 values. 10 more will be 41. And then 50 values will be till 51. So 51 here. And then I just replicate this formula till the end. Sorry, it's there. See, so there I have 50 values, isn't it? So I'm going to copy this like that. Then move to copy this, because the formula is active, so it's changing all the time. So I had to make sure that okay, so I had to make sure that this is fixed. That's why I do the copy paste, and then I do the paste special values, right? So I'm going to, of course, I'm going to delete those ones. I don't need them anymore, like that. So now I'm going to generate the same formula for all of them. Okay, to make those 50. Okay, so 50. Okay. So now I'm going to make this cumulative value. And now the average value is exactly the same formula. Right? So now let's see what happened. So again, let's try to graph again, just to have a look, the first 10 values of those figures. So if I do the first 10 values, let's see how they looks like. Again, I don't see that they got stable. My impression is that the value is going down, then goes up, then goes down, go up, go down, go up, and I don't know what is happening. I don't know what is going to happen after the 10th value. Probably it's going to go up, it's going to go down, I don't know. So what will happen if now I draw all of them, the 50 values? Hold on. Sorry, it's a bit slow, my computer. Hold on. This manual. Okay, so let's see what happened if I do all of them. which means that now I'm looking at 100 values, 50 values. So if I draw this, as you can see now, the graph looks now more stable. In fact, when it was in 10, the value was expected to go down again, so it was not stable. But now I can see that after the figure, let's say 27 more or less, the data is start looking very stable. So with 50 simulations for this particular case must be enough. The same case apply for the quality that we got from Dgrai. This means that whenever I'm going to run a simulation and whenever I get the data from the txt file, I need to do this exercise and calculate the average accumulative value for all the data, graph the data, and then see if the graph looks stable or not, as is this case. Of course, that eventually, if I draw more data, let's say if I get 100 data, actually we could try to do that if you want. So if we get 100 data, we should see that the graph will look pretty similar, like a line, so it's very stabilized. But at the moment, with this exercise, we can realize what this average cumulative value really means. I'm going to put the two graphs together, and to be honest, this is a very good analysis when we are running simulations, because eventually it's very difficult to know if we got enough data. And with this, we can easily realize that if we need more simulation, or if we need more time to be run to see how the result looks like. So as you can see, this 10 value, the 10 figure is exactly here. So we can't say that this is stable, because eventually we'll go down. So we can say nothing about the simulation at that time. So eventually that is telling us that we should run that, or at least that we should have run more data. All right, so with this clear, now the next video is about to explain how the decision center's quality looks like and how we can get that data from the simulation model. More information about that in the next video.